regression, let's put that event in here too. What the heck, we got time to do it. Stat time series plot. Simple time series plot of target revenue. Now what happened here? Wasn't there a kind of a drop off right here? What observation is that? You put the cursor over it, it should tell you. That's the 17th observation, you see that? See it drop down there on the 17th? So let's put a dummy variable in for that shift. Because it was growing at a pretty rapid rate, then it shifted down, it's growing at a different rate, don't you think? So let's put a dummy variable in that explains that event. Let's call it the recession, okay? Everybody agree that we could try something like that? So let's insert a column and then put recession in. And we said we wanted to turn that on at the 17th observation. So what do? With zero fill, now I'm creating something called a categorical variable. Let me go ahead and pull this up. It's categorical because it only takes on specific values. And we turn it on 17. I'm going to leave it on for the rest of the data series. I think I got 25 observations. Now I got more than that. I need to take the whole that out of this, but we're not going to mess with the forecast today. You guys make sure you take your holdout out. In fact, I guess I shouldn't I? Let's nuke this one. 1, 2, 3, 4, 5, 6, 7, 8, right? Did I get 8 of them? Yeah. Control X. Did I not do it right? V. This is the forecast date. And this is del rev, which we're not going to use. All right. Give me a chance to fix it. Target holdout. Recession dummy. We'll just call it recession forecast. CPI forecast. No, it's unemployment, isn't it? This is CPI here. This is what? Retail wages. This is sales and ad. And this is, last but not least, is Walmart. Okay. I'm going to continue this recession forecast. I'm going to assume that the recession effects still hold during that time. All right, let's run the model. Stat, regression, fit regression model. Target sales. We're going to put the recession down here. Actually, we're going to put the recession as a categorical variable because it can only take on values of 0 and 1. It's not continuous, right? There are no decimal points or no digits besides just those two values. So it's restricted. So I'm going to put recession down in the lower one. And I'm going to use up here in the continuous side, since it's continuous data, it can take on almost any values. It's not restricted. And there we go. Okay? I'm going to store well, let's don't store anything. Let's go ahead and run the model. And let's go under results and make sure you check the Durbin-Watson statistic. Under results, select OK. And this is the model we get. See, we've got a Durbin-Watson value down here. Let's go back up to the top where the model run begins. Look at the F statistic. The F value for this should be around 8 and change, 3 times the table value. It's sitting at 56, which means good. So the probability of that statistic being 0 is 0, essentially. So look at the R-squared adjusted. We're explaining 93.25% of the variation in Y, which is not too bad. Let's look at the significant variables. Constant term, we're going to allow that to hold regardless of its significance level. Unemployment, okay, it's significant at 2.92 t-value and a 0.009 b. CPI is significant. Retail wages is significant. Target sales and advertising expense is significant. And Walmart revenue is not significant, and neither is a recession. Okay? So the recession didn't pan out for us. So we're going to have to take it out along with Walmart sales. And look, we've got two. Look at the VIF factors. We've got 2 highly autoregressive terms and another one that's highly autoregressive to it too. So these 3 variables are essentially overlapping one another. So I'm going to try to take out 2 of these, Walmart revenue and recession, and see if we can bring unemployment back into the fold. So let's go to stat, regression, fit regression model. I'm going to take out the Walmart revenue. I'm going to take out the recession down here. And we'll rerun the model. Durbin-Watson statistic went up. VIF factors. We still have CPI. Now I could try a transformation of CPI. I could square it or take the reciprocal of it or log form of it. I'm not going to do that. I'm just going to take it out. Stat times zeros, or regression, excuse me. Fit regression model. I'm going to take the CPI variable out because it's causing multi-collinearity with these two other variables, unemployment and retail wages. Okay? So let's take it out and rerun the model. Durbin-Watson fell, which is good. And the VIF factors are all okay now. The t-values show significance. This one's close, but it shows significance. And we explain approximately 87% of the variation in Y with the model. And it's got a high F value. It's higher than the table 8.2, I think is the table value for this.
What does it mean right there where it has your constant coefficient?
Right here? That's the
showing
intercept term. That's the alpha term.
the negative, does that mean anything?
It's negative. It takes on a negative value. That is when all of these other variables are pushed to 0, you have a loss in terms of target revenue.
Oh, okay.
Some to the tune of 79, almost $80 billion. Okay? That's what that means. It's just the intercept value that the linear function for the forecast model was derived from. And it is a value that Y takes on when these other variables aren't used to don't explain into the variation. All right, that is, they fall to 0. Does everybody understand how we do that? So, if we wanted to forecast with this model, we go to stat, regression, not fit regression model, but now in Minitab 17 you have something called predict. You see that? So you got the model and you feel confident in it or with it, and we're going to use it to predict. We're not going to enter the values, we're going to enter the columns, so make sure you select that. And what it'll do is highlight the X variables, and you need to put in the forecast for each of these X variables, which we've already labeled. Unemployment forecast is right here, retail wages forecast is right here, target sales and ad expenses there. Okay. And why do you not have to put the number of periods that you're going to forecast in this? Do you guys ever think about that? Because it's only going to forecast relative to the number of X variables that you've got to forecast. Right? So you don't have to put in 8, because you already got the 8 explained in each one of those variables. You got 8 in one of them, right? So it'll generate 8 forecasts values. Naturally, you want to store those. Now, you don't care about the prediction fits of the forecast values. Don't care about the standard error in this case, and we don't care about the prediction interval, but we do care about the confidence interval. Say okay, select it. And under, say that's okay. But we want what? Yeah, that'll do. So we should have a forecast for the X variable. If I can get this to expand, it'd be great. I'll just move this over. Okay. You have something called P-fits. That's a forecast value. And lower limit. Upper limit. Okay. We can see how well the forecast behaves, stat or graph, either one, time series plot. Do the multiple. So plot the holdout, target holdout with the forecast value and the limits. And you've seen this before. This is where we left off last time. Oops, don't need 2 plots of lower limits. And we saw that the forecast is not that hot from the standpoint of it falling out of the confidence limits. So you really can't have confidence that this forecast is good. It's an indication you have to go back and refine it. And what do you think's missing out of this? Let's go back to the model itself and see what's missing. And what we need to do is run the model again and say the residual stat regression. We should have done this before we moved on to the forecast. Fit regression model. And we're going to go to storage, and we're going to save the residuals. Okay? And I'll save the fits too, just for the heck of it. And let's go to graphs and look at the 4-in-1 plot. This is going to tell us all about what this model left behind and why it's not, the forecast is not in the relevant range. Okay, select OK. Now it's produced some more information for us. It's given us fitted values along with the residuals. Everybody see that? So when I did the storage for the residuals, you just put the residuals in the worksheet. Now what I can do is do a time series plot. Or better yet, let's do this. Because we've seen a time series plot of residuals, haven't we? This, in fact, I think it's in the 4-in-1 plot that we've got right here, right? This is a time series plot of residuals. What do you see in those residuals? Tell me. What do you think? They're oscillating around 0, but they do have seasonality in them. See the, and they're also, looks like it's got trend or cycle in it. See this? It's kind of a tendency for it to have a wave in it. And you can see that the residuals are not normally distributed, so they're clearly not random, right? And are they heteroscedastic? It's a question I got to ask you. You think they are? Due to the fact that the error does increase somewhat due to seasonality, I think if we cure that problem, we can do away with the heteroscedasticity. There is not really a megaphone effect here, to be frank with you, just misstated. And there's no really decisive pattern in these. If you see the residuals versus fit, and they do have a pattern, especially an explosive pattern here toward this end of it, and the more narrower end here, or you have a megaphone effect here, and you've got heteroscedasticity. And we're going to try the BK test for heteroscedasticity in this class, and I'll show you how that's done. So there is a statistic we can derive. It's called a BK statistic or test. But there's some systematic behavior that we're not explaining. We can go to stat, time series. How can you find out what it is or identify it? You can do an autocorrelation of those residuals, can't you? Let's just do that. I didn't want to default the number of lags. Let's put 25. It's got, yeah, let's put 30 in there, see if it'll take it. No, it doesn't have it. We only have about 25 observations, don't we? Do one less than the number of observations. What do you say? 1, 2, 3, 4. Isn't that seasonality? It's showing up again in the 8th period. So we don't have anything as explaining seasonality in that. We have seasonality in the Y variable, but we don't have anything to explain it. So we're going to create an event. This is where we left off last time too, in terms of creating an event to capture that seasonality and take it off the table and hopefully improve the forecast. So I'm going to kill this. Go back to the data series that we had. If I can find out where that is. There we go. And instead of recession forecast, I'm going to clear that. Clear cells. And this inserts more columns. I'm going to insert 3 columns, and we're going to call, remember the events, what did we say? We're going to leave Q1 out. We're going to start with Q2, Q3, Q4, right? We had to leave one of those out because we didn't want to introduce multicollinearity. We left one of them out. All right, this is, go to the top of the line, and this begins in Q2, doesn't it? So this is a 1, Q3, no. Q4, or Q3, Q4, 0, 0. See the diagonal? Then for Q1, the one we left out, we'll fill it all with 0. So what I'm going to do is just take this, Control copy, Control V, put it down here. Data series. That's for the forecast values. Now we need to do the same thing for the actual data. So I'm going to clear this cell. Clear cells. I'm going to insert some more columns. Q3 dummy, Q4 dummy. Starts in Q1. 0, 0, 0, 0. Q2, isn't that right? Yeah, this is Q2. That's 1 there. 0, 0. Q3, 0, 0, or 0, 1, 0. That's when those they appear. 0, 0, 1. And what I'm going to do is just copy this and do the same thing we did with the other. Copy. Because just repeats, Control V. Control V. I'm going to copy all of this. Come on. Control copy. And just paste it. Keep going until I run out of data. It's 01001. This is first period. Okay? Let's run the regression again. Everybody with me on what we did? We created dummy variables, one for each quarter. We tried the recession, it didn't work. We're going to try it to get the seasonality out. So we're going to go to regression, regression, fit regression model, run it with these variables. Q2 dummy, Q3 dummy, Q4 dummy. Okay? Looks like we've removed some of the variability. Let's see if I can find another one. This is the way it looked previously. Look at the scale. This is what, 10,000 to negative 5,000? This is still negative 5,000, but it doesn't go up to 10,000. So the variability has been reduced. And it looks like we've absorbed some of that seasonality that we saw before, haven't we? With those explanatory variables. And it doesn't show as much in terms of heteroscedasticity, since we explained it. You know, there's not any widening of the residuals versus orders we got. There's not necessarily a pattern up here we can see. So we don't have the heteroscedastic set of residuals. So I don't think heteroscedasticity is a problem. This is definitely